So now you're ready to divide rational expressions. That's not very far from multiplying rational expressions, which we also learned is pretty much the same thing as simplifying. So hopefully this will go smoothly. Basically, we never divide by a fraction. Instead, we always multiply by the reciprocal. So this first rational expression, we're going to leave exactly the way it is. So this is 4x to the third divided by 9x squared y. So nothing changed with my first rational expression. Now, instead of division, I'm turning it into multiplication, and I need to do the reciprocal. To do the reciprocal, I flip the top and the bottom. So the 16 used to be on the top, now it's going to be on the bottom. The 9y to the third used to be on the bottom, now it's going to be on the top. So 9y to the third. Now it's a multiplication problem, which is what you just got done doing. And you also discovered that that's basically the same as just simplifying. So the two 9s are going to cancel out. For the 4 goes into 4 one time, it goes into 16 4 times. I have 2 x's on the bottom that I can get rid of as long as I get rid of 2 of the 3 x's on the top, so that leaves me with 1 x. I can also get rid of this y from the bottom as long as I get rid of 1 of the 3 y's, so that's going to leave me with 2 y's left over. So now I have 1xy squared, so that's going to be xy squared, over the only thing that was left in the denominator is a 4. Here's the part that gets a little bit tricky, doing the domain restrictions. The domain restrictions are going to come from anything that was ever in the denominator. So that's always going to be this and this, because they were in the denominator to start the problem. And then when I multiplied by the reciprocal, this numerator became a denominator. So we are always looking at these 3 spots for our domain restrictions. So in this example, that means that x and y can both not be 0. So x cannot be 0, y cannot be 0. If you have a problem that looks like this, your first step is to factor everything that can factor. You want everything completely factored. So on this first one, if I factor out, they both have x to the third. That's my GCF. So if I factor out x to the third, that leaves me with x squared minus 4. So I've replaced this. But this is not completely factored yet. So I still have my x to the third, but this is a difference of perfect squares. So that's going to factor into x plus 2 and x minus 2. This one is going to factor into x minus 2 times x plus 1. You're probably starting to figure out, if you're not very good at factoring, this chapter is probably going to be very difficult for you, and you're going to want to come in and get some help on that. For this one, I can factor out my x to the third first. That's going to leave me with x squared. Oh, I should be doing this in blue because I'll factor again. So I'm factoring out my x to the third. That leaves me with x squared minus x minus 2. Well, this part right here can factor again, so I have my x to the third still. And then this factors into x minus 2 times x plus 1. And then this one is a difference of perfect squares, so that's going to factor into x plus 1 and x minus 1. So remember, we don't divide fractions, we multiply by the reciprocal. Before I do that, I just want to remind you that for our domain restrictions, it's going to come from any of these 3 locations. Now, we do not need to rewrite them if it's a repeat. So, for example, I have an x plus 1 and an x plus 1. I don't need to put negative 1 twice. We just know that x cannot be negative 1. So when I go to do my domain restrictions, I'm going to get it from these locations. Before I get to that point, I still need to actually do the simplification. So I'm going to leave the first fraction alone, but leave it simplified. So I have x to the third and then x plus 2 and x minus 2. The denominator of that, the simplified factored one, is x minus 2 times x plus 1. Now instead of division, I'm turning it into multiplication, and now the denominator of this problem is going to become the numerator. I should have crossed out some of these so that they're not so confusing. So this denominator is now my numerator, so I have x plus 1 and x minus 1. And my new denominator is what it used to be in the numerator, so x to the third, x minus 2, and x plus 1. Now I'm ready to cancel anything from the top with anything from the bottom. So I have x to the third cancels with x to the third. I have an x plus 1 and an x plus 1, an x minus 2 and an x minus 2. Some of you are going to be tempted to cancel out parts of these. They're not the exact same. So here, my numerator is going to be x plus 2 times x minus 1. And I'm not going to expand that out. I'm going to leave it factored. My denominator is going to be x minus 2 and x plus 1. And then I still need to do my domain restrictions. I need to say what x cannot be equal to. So x cannot be 2 or negative 1. Here it can't be 0. Here it can't be 2, but I already have that on my list. Here it can't be negative 1. I already have that on my list. Negative 1's already on my list. Here it can't be positive 1. So I have 4 domain restrictions, 2, negative 1, 0, and 1. So this entire thing is my final answer. Here's what I get when I divide my rational expressions, and here are my domain restrictions. So you should be able to do the homework that's listed over on the right now.